So in this video, we're going to talk about how to describe transformations of cube root functions. So the parent function of all cube root functions is f of x equals the cube root of x. And then every other cube root function will be a transformation of this original parent function. We can have values of a, b, h, and k added in, and those are all constants. So there are three types of transformations that we can see. You can see shifts, which are also called translations, stretches or compressions, and reflections. So here is this picture that's in your study guide also. So make sure that you're using this when you go through the practice problems, because it tells you when you're looking at these transformed functions, if you see a value of a, okay, remember anything on the outside like an a or a k is going to be a vertical change. A can create a vertical stretch if the absolute value is greater than 1, compression if the absolute value of a is less than 1. It'll be a reflection over the x-axis when a is less than 0, because remember that means a is negative. The value of k will also be a vertical change. Remember, the graph will go up when k is greater than 0, and it will go down when k is less than 0. B and h are on the inside of the root, so that means they're going to be horizontal changes. It's going to be a horizontal stretch when the absolute value of b is less than 1, compression when the absolute value of b is greater than 1. It'll be a reflection over the y-axis when b is less than 0. So h is going to be kind of doing the opposite of what we think, okay? Because if h is less than 0, it's going to look like a plus sign in our problem. It's going to be like x plus h, and that's actually going to shift left. If h is greater than 0, that's going to end up looking like a minus sign in our problem, so it's actually going to shift our graph to the right. So let's look at some examples. So what I like to do when I'm looking at these problems is I look at the parent function, right? So it's f of x equals the cube root of x. And then I look at the transform functions and I kind of list out all the values that have been changed. So for example, here I see, well, there's a 1/2, right? And then there's an x minus 4. And then I have a plus 5. And then you can use one of the charts in the study guide. I kind of like this flow chart, so I'm going to use that for these examples. But if you like this chart, you can also see that in your study guide. So what I'm going to do here is I'm going to figure out where the position of these numbers is and how that affects the graph. So 1/2 is on the outside, right? It's outside the radical. So that means it's a vertical change. 1/2 is multiplying my radical. So that means it's going to be a compression or a stretch. Well, 1/2, if I take the absolute value of that, the absolute value of 1/2 is equal to 1/2, which is less than 1. So that means I have a vertical compression. Okay, so that's how you can use this chart to figure out the transformations. Okay, so now we have an x minus 4, right? So that minus 4 is on the inside of the radical. Okay, so inside means horizontal. It's being added or subtracted. So when I see that minus sign, it's telling me it's actually shifting to the right. So this is going to be a shift right 4. And then I finally have that plus 5. That plus 5 is on the outside. Okay, outside is a vertical change. It's being added or subtracted. So that means it's a shift up, right? Because plus 5 is greater than 0. So k is greater than 0. So that's going to go up 5 units. So remember, you always want to use Desmos to check your answers, because that way you can be 100% sure that you're right. So what I'm going to do now is in Desmos, I'm going to graph the parent function and the transform function and see if I do actually have these three changes, okay? So you can see here in black, I have the parent function. In green, I have the transform function. And you can see that it is in fact vertically compressed. It has been shifted to the right 4 units, okay? You can use this kind of the center point to see that comparison. And it's also been shifted up 5. So now let's try this example. The function f of x equals the cube root of x is transformed to negative cube root of x plus 2 minus 4. Describe the transformations. So when you have that minus in front, you want to think of it as its own transformation. It's basically like there's a negative 1 right there. So if you want to, you can think about that as a transformation of negative 1. I also have this plus 2, right? And then I have this minus 4. Okay, so let's use our flow chart. So the minus 1 is on the outside, right? So that's vertical. It's multiplying the radical. It's not a compression or a stretch because the absolute value of negative 1 is equal to 1. So that's neither less than or greater than 1 because it's equal to 1. However, I do have this transformation right here, right? It's a reflection over the x-axis when a is less than 0. So this is negative 1 is less than 0, so it's going to be a reflection over x-axis. Another way you can think about it is anytime you see that negative in front, it's going to be reflected over the x-axis. Now we have that plus 2. The plus 2 is on the inside, so that's a horizontal change. It's being added or subtracted. Okay, so that plus 2, I have that plus sign, so it's going to be shift left. So this is going to be a shift left 2. And then finally, we have this -4 that's on the outside. That's a vertical change. A -4, that's a subtraction. So that is going to go down because k is less than 0. So we're going to say that is going to go down 4 units. Okay, so remember, you always want to double check in Desmos, right? That's like a way to make sure you have 100% right. So just go ahead and graph the parent function and the transform function, and you can see that it is in fact reflected. It's shifted to the left 2, and it is gone down 4. So now you can go ahead and pause the video and try doing this example on your own. So you can see here when I transform the cube root of x to 2 cube root of x minus 4, I have 2 transformed values, right? I have this 2 and the 4. The 2 on the outside creates a vertical stretch. The 4 on the outside is being subtracted, so that's going to be a shift down 4. If you graph both functions in Desmos, you'll see that they have the same transformations we figured out. So remember to use this chart whenever you're trying to figure out cube root transformations, and depending on the values of a, b, h, and k, you'll have different transformations that you can also see in Desmos.